Exercise we're going to look at is 6E, fitting a trend line and forecasting. This is the final exercise in our time series component, and I think you should be okay to do this one. Fitting a trend line. If there appears to be a trend line, we can use the least squares method to fit a line to the data to model the trend. We did that in our last SAC, fitting trend lines, least squares regression. We know what we're doing with this. Fit a trend line to the data in the following table, which shows a number of government schools in Victoria over the period 1981 to 92, interpret the slope. So with this one here, they've used the time code here when entering the data in the calculator, right? So instead of writing in 1981, 1982, 1983, etc., I've done this in the CAS. I've gone year 1, 2, 3, 4, 5. And you'll notice that happen in a lot of questions in regards to time series. You'll do a time code. So 1981 in this case is year 1 for the data they're looking at. So you put that in there, and if you have to fit a trend line, don't worry about doing the linear regression here. Just go to the home button, histogram, let's put in year, let's put in number, and there's our dot plot that's very similar, isn't it? And if you want to fit that trend line, regression line, we know what to do. We go menu, analyze, regression, show linear, and there is, you can even move that around if you want. There is our regression line. So see how y is number of schools, number, equals negative, I've done mine around the wrong way there, haven't I? So hang on, I'll even get rid of that. I might even fit a different trend line so you can see it. Analyze, I must have picked a different one there. I want to pick this one. I thought I did. So there we've got our regression line. It looks like this one in the book, 2169, 2169. Minus, see it's got plus minus, that just means positive negative make a negative, minus 12.5. So what's happening here, if we have to interpret the slope, over the period 1981-92, the number of schools in Victoria decreased at an average rate of 12.5 schools per year. So that's what's happening there. It's going down, isn't it? It's a decreasing trend, so it's losing 12.5 schools on average per year. Let's go to the next question. Forecasting. Now, forecasting is just when we put a value into our trend line, okay? So how many government schools do we predict for Victoria in 2015 if the same decreasing trend continues? Give your answer correct to the nearest whole number. So since 1981 was year 1, 2015 is year 35. That's just how it works, okay? So if we designated 1981 as year 1, then 2015 is year 35. So we use our equation, if you want to see how this works, calculator, we got 2169, and we're going to minus 12.5 times the 35th year, so that's where we get 1732. See, it's got little squiggly equals, that means about that, and because it's 0.5, that's why we ran up to that many. And this part here is just talking about extrapolation. See how that comes up a lot? We know it does. Forecasting taking seasonality into account. So this is the deseasonalized data that we learned about in our last exercise. So these are the different quarters at Mickey's shop. It's still from Mickey's shop if you want to look at the last video. So we've got to plot that time series data. So I've put in over here, I put it in somewhere actually. Where did I put it in? Oh, there's Mickey's quarterly. The quarters, and we've also got the sales. So if we're going to do a trend line on this one, same thing, home screen, histogram, we've got quarter, we've got sales, and if we want to fit a trend line, we've also got to fit the time series. So we've got to do the X1 line, and then we've also got to do the regression line. You know how they like this second one. So there is our actual data there. So, if we have a look at this, over the 3-year period, we're interpreting the slope now I should say, sales at Mickey's shop increase an average rate of 32 sales per quarter, because that's what that 32 means. It's going up by 32. That's the trend line, alright? So interpreting the slope. Let's keep going down here. Making predictions with deseasonalized data. You can read this part. I'm going to go straight into the question. What sales do we predict for Mickey's shop in the winter of year 4? Remember, Because many items have to be ordered well in advance, retailers often need to make such decisions. This is where it's coming to real life stuff, all right, the extrapolated data stuff. So this talks about one of the other examples we had. Substitute the appropriate value for the time period in the equation for the trend line. Since summer year 1 was designated as quarter 1, then winter year 4 is quarter 15. Does that make sense for people? We go up here. These are the quarters, if they're quarters. Year 1 finishes after 4 quarters. Year 2, year 3, and then we started in summer, so we need 3 more seasons to get to the winter. That's where the 15 comes from. So we use that equation we've already got, put it in the calculator, just like I did before, and there is our value, and you'll find the same thing on your calculator. But if we then have to seasonalize the data, and this is from our previous exercise as well, remember we have to use that value and we multiply by its seasonal index. It's a smiley face. Hopefully this helps.